Rockets are like really powerful cars, but instead of driving on roads, they fly into space. They are designed to carry things, like satellites or astronauts, far beyond Earth. We launch rockets to learn more about our planet, our solar system, and the universe. Some rockets even carry telescopes that help us see distant galaxies.
Have you ever noticed that rockets have a special pointy shape? This isn't just for looks. The shape of a rocket is called aerodynamic, which means it's designed to move through the air with as little resistance as possible. Think of how a bird's wings are shaped to help it fly smoothly. A rocket's shape helps it cut through the air and reach incredible speeds. Let's dive deeper into why this shape is so crucial. When a rocket is launched, it has to overcome the force of gravity pulling it back down to Earth. To do this efficiently, it needs to minimize the drag, or resistance, it encounters as it moves through the atmosphere. The pointy, streamlined shape of the rocket helps to reduce this drag significantly. Imagine trying to push a flat, blunt object through water. It would be tough because the water would push back against it. Now think about pushing a sharp, pointed object through the same water. It would move much more easily because the water flows smoothly around it. The same principle applies to rockets moving through the air. Over the years, rocket scientists and engineers have studied and tested countless designs to find the most efficient shapes. Early rockets were often less streamlined and faced more resistance, which made them less efficient. Modern rockets, however, have been optimized to have the perfect aerodynamic shape, allowing them to travel faster and farther than ever before. Just like birds have evolved over millions of years to have wings that allow them to fly with minimal effort, rockets have been designed with precision to achieve the same goal. The fins and body of a rocket are carefully crafted to ensure that it can cut through the air with ease, reaching the high speeds necessary to break free from Earth's gravitational pull. So, the next time you see a rocket launch, take a moment to appreciate the incredible engineering that goes into its design. The shape of speed is not just about looking sleek and futuristic, it's about mastering the forces of nature to achieve the seemingly impossible. From the delicate wings of a bird to the powerful nose cone of a rocket, the principles of aerodynamics are at work, enabling us to explore the skies and beyond.
Rockets need a lot of power to escape Earth's gravity. That's where fuel comes in. Rockets carry special fuel that burns and creates hot gas. This gas shoots out of the bottom of the rocket with tremendous force, pushing the rocket upwards. It's like when you blow up a balloon and let it go. The air rushing out propels the balloon forward.
Section 4. Staying on course guiding rockets to their destination. Launching a rocket isn't as simple as pointing it at the sky and pressing a button. Rockets need to be carefully guided to reach their destination. This is done using computers, sensors, and small rockets called thrusters. These systems work together to make sure the rocket stays on track and adjusts its course if needed.
Section 5. Building a spaceship, parts of a rocket. Rockets are complex machines with many different parts, each with a specific job. The main parts include the payload, which is what the rocket is carrying, the guidance system, often referred to as the brain of the rocket, the fuel tanks, where the fuel is stored, and the engines, where the fuel is burned. All these parts work together to make space travel possible. Let's delve deeper into each of these components to understand their roles and significance in the grand scheme of space exploration. First, the payload. This is arguably the most crucial part of the rocket because it represents the purpose of the mission. The payload can be a satellite, scientific instruments, or even astronauts. For instance, when launching a satellite, the payload is designed to be deployed into orbit to perform tasks such as communication, weather monitoring, or scientific research. In manned missions, the payload includes the crew module, life support systems, and other essential equipment to ensure the safety and success of the astronaut's journey. Next, we have the guidance system. This sophisticated technology is often referred to as the brain of the rocket. It includes computers, sensors, and software that work together to navigate the rocket's path. The guidance system ensures that the rocket follows the correct trajectory, adjusts for any deviations, and reaches its intended destination. It is responsible for making real-time decisions and corrections during the flight, which is critical for the success of the mission. Without an accurate guidance system, the rocket could veer off course, leading to mission failure. The fuel tanks are another vital component. These tanks store the propellant, which is the fuel and oxidizer needed for the rocket engines to function. The type of fuel used can vary depending on the mission requirements. For example, liquid hydrogen and liquid oxygen are commonly used in many rockets due to their high efficiency. The fuel tanks must be designed to withstand extreme conditions, such as high pressure and low temperatures, to ensure the safe storage and delivery of the propellant to the engines. Finally, the engines are where the magic happens. The engines burn the fuel stored in the tanks to produce thrust, which propels the rocket into space. There are different types of rocket engines, including liquid-fueled engines, solid-fueled engines, and hybrid engines. Each type has its advantages and is chosen based on the specific needs of the mission. The engines must be incredibly powerful to overcome Earth's gravity and reach the desired altitude and velocity. In addition to these main parts, rockets also have other essential components such as the structure, which provides the framework and support for the entire rocket, and the avionics, which include the electronic systems used for communication, navigation, and control. The structure must be lightweight yet strong enough to withstand the forces experienced during launch and flight. The avionics systems ensure that the rocket can communicate with ground control and receive commands throughout the mission. All these parts work in harmony to make space travel possible. The design and engineering of rockets are a testament to human ingenuity and our desire to explore the unknown. Each component, no matter how small, plays a critical role in the success of a space mission. Understanding the parts of a rocket gives us a greater appreciation for the complexity and precision required to venture beyond our planet.
Section 6. Conclusion: Rockets unlock the universe. Rockets are amazing feats of engineering that allow us to explore the vastness of space. By understanding the basic principles of aerodynamics, propulsion, guidance, and structures, we can appreciate the incredible science and technology that goes into every rocket launch. Rockets have been a symbol of human ingenuity and ambition for decades. From the early days of space exploration, when the first satellites were launched into orbit, to the modern era of reusable rockets and ambitious missions to Mars, rockets have always been at the forefront of our quest to understand the universe. The journey of a rocket begins long before it ever leaves the ground. It starts with meticulous planning, design, and testing. Engineers and scientists work tirelessly to ensure that every component of the rocket is perfect, from the engines that provide the thrust to the guidance systems that keep it on course. The launch of a rocket is a moment of immense excitement and anticipation. As the countdown reaches zero, the engines roar to life, and the rocket begins its ascent into the sky. The sheer power and force of a rocket launch are awe-inspiring, a testament to the incredible capabilities of human technology. Once in space, rockets continue to play a crucial role. They transport satellites that provide us with vital information about our planet, enable global communication, and even help us navigate our daily lives through GPS technology. Rockets also carry scientific instruments that allow us to study distant planets, stars, and galaxies, expanding our knowledge of the cosmos. As we look to the future, the role of rockets will only become more significant. With plans for manned missions to Mars, the establishment of lunar bases, and the exploration of asteroids, rockets will be our vehicles to new frontiers. The advancements in rocket technology, such as reusable rockets, are making space exploration more sustainable and cost-effective, opening up new possibilities for discovery and innovation. In conclusion, rockets are not just machines. They are symbols of our desire to explore, to push the boundaries of what is possible, and to unlock the mysteries of the universe. As we continue to advance in our technological capabilities, rockets will remain at the heart of our journey into the unknown, guiding us to new discoveries and adventures in the vast expanse of space.
Thanks for tuning in. If you enjoyed diving into the latest in science and tech, don't forget to like, share this video, and subscribe to Orbit Lounge for more insightful content. Hit the bell icon too, so you'll never miss an update on our journey through innovation and discovery. See you next time.